This video discusses how to insert nodes into a linked list. Essentially, there are three basic cases that we need to consider. We could be inserting a new node at the front of an existing list. We could be inserting a node at the back of the existing list, or we can be inserting the new node somewhere in between, which means not necessarily at the front, not necessarily in the back of the list, but somewhere in between two nodes. And this is typically done when we have a list which is already in order, let's say alphabetical order or increasing order, and then we want to maintain this order. So typically a linked list looks like this. We have introduced linked lists in a different video, in a previous video, but let me review the concept. So essentially, we have the collections of nodes. The collections of nodes are linked to each other by using a reference. This reference is called next, with the idea that every node has a reference to the node that follows the previous node. So this is a reference to T. So we said that T follows G. This is a reference to the node that has O. So we said that the node next to T is O. And finally, the reference here is null. Remember that in Java, a reference has only two values. Either it refers to a new object, like this next, or is being set to null, saying, I don't have an object to refer to. Finally, a very important component of any linked list is external reference that we call front, we call head. It has different names, but the objective is always the same. This is a reference that is going to tell us the address of the first node in the list. This reference is going to be used to start traversing the list or accessing the list using the first node. Keep in mind that this is an external reference, it's not a node. The only information that this contains is the address of the first node in our linked list. So now let me show you what the idea behind all this is. So we're going to have, again, a linked list that has n numbers of nodes. Here I only have 3 nodes, but think again in terms of a very large numbers of nodes. So it's a list where we know where the front is, we know where the end is, and now we're given the task of introducing or adding to this list a new node. So the assumption for this discussion is going to be that I have a reference that I call new node. It could have a different name like temp, for example, but the bottom line is that I have a reference that tells me where the new node that I'm going to insert is located. That new node has been created, memory has been allocated to it, and the field next of that node has been properly initialized to null, because right now this is a standing alone node that is not linked to anything. So my task is to link this node or insert this node at the beginning of this list. So let's discuss the code. So typically we write a method, and this method is called AddToFront. There are different versions or many ways in we can write this method. For example, I could write the method and return a Boolean value to indicate success or failure, or I can return the value that is being added. In this case, I'm writing a method that is void, and the parameter that I'm passing is a reference. It's a reference to the node that I want to insert at the front. The code is very simple. There are going to be two cases. Either the list is empty or the list has n numbers of nodes. If the list is empty, then all I have to do is to say, oh, the value of the reference that marks the beginning of the list should have the same value as this reference that I'm calling new node. In order to decide that, I do a basic test, which is to ask what the value of head. Remember, head is the equivalent of front, is a reference to the beginning of the list. So if head is null, if this test is true, that means that I have no list. There are no nodes in my current list. So all I have to do is to say, well, then head, which has the address of the first node, should be referring to the same thing that the new node has. So at this point, my list will have exactly one node. The else means that the head is not null. What does it mean? Well, it simply means that I have a list. I don't know exactly how many values I have on the list, but what I do know is that head has an address. And if it has an address, then there is a list. So what I want to do in this else then is to insert a new node in front of that list. So how do we do that? With two simple statements. So let's follow this diagram here. My current list has 20 and 30. Okay, 30 is the last node. The first node is being referred to by head. And in this case, obviously head is not null because head is referring to this node that has value 20. So what I need to do first is to link the new node to the existing list. So my new node has value 10. I want to insert it at the front. So what I had to do is to say, all right, let's go to the new node. Let's access the reference that I call next and set that value to be the same value as the head. In this diagram, let's just start backwards. What is head? Head is referring to the first node, the one that has value 20. What is this next? This next is the next reference of the node that I want to insert. So what I want to do is to change it, all right? So I'm going to say new node dot set next, which is this, and assigns to it the value head. So this is the blue arrow. So now I have two references referring to the first node, what I'm calling head, that tells me where the list starts, and then what I call next in the new node. Now, this becomes the first node on the list. Therefore, I need to reset the value of head. And I reset the value of head by simply saying, oh, the new value of head is the value of new node. Why is that? Well, because the new node refers to the value that needs to be inserted. So now head is going to refer to the node that has 10. So at the end, I will have head that signals the beginning of the list that refers to the node that I just inserted that has value 10. And that one, it will tell me what the rest of the list is. So the next node is the one with value 20, the next node is the one with value 30, and the next node is set to null, which means that's the end of the list. So to summarize what we had done was two things. One, we connected the new node at the beginning of the list because we're trying to insert at the front. And then I updated or relocated the values on front and new node by making front value be the one that I was just inserted at the beginning of the list. So again, front tells me where the list starts. It starts with the new node that I inserted that has value D, and that one is connected to the rest of the existing list as I have it earlier on.